Hello. This video is to demonstrate the Q2 system, which is the latest advancement for the Quench program. It utilizes new technology which drastically cuts power consumption and increases field reliability. The Quench program, as you know, is a prepaid billing system for communal water kiosks worldwide. It provides transparency in pricing, on-demand water, and monitors usage for maintenance and operation. One of its biggest benefits, though, is the ability to move tap heads closer to people's houses, because a water attendant is not required to be there for payment or distribution. This has huge impact on quality of life and communal hygiene, because people don't have to transport water great distances. We're looking for partners to help us develop and implement a pilot program to document these benefits. The new Q2 system is about 1/4 the size of the original prototype and can be packaged in a variety of ways. The electronics and plumbing can be packaged in a standalone kiosk, which we've demonstrated before, that comes in for about 1/10 of the cost of current water kiosks. And it also has a very, very small footprint. This particular packaging concept is for retrofitting current water kiosks or tap stands. It has a small user interface that would be close to the tap head where people could turn on and off the water, and it has a small valve manifold that can be buried near the tap head or installed inside of the water kiosk. Now, one of the biggest reasons that the Q2 system can be this small is because the electronics have gotten very, very simple. We had significant wiring before, which made the system not field ready. But with advancements and off-the-shelf parts that have just become available, we have been able to whittle the electronics down to this brick, which comes in for about $150, and that includes the plumbing and manifold system. So if we look at assembly, shipping, and installation, a target price of about $500 per unit is very realistic, which means that for a pilot program for 5 different kiosks serving 50 people each, we're looking at about $5,000 installed on the hardware cost. That's tremendous. Now, the operation is still the same. You go and load your Quench card by prepaying for water, jerry can units. You come over and you would stick that into the kiosk, turn on the switch, at any time you can cut the water, switch out vessels when needed. And when one jerry can has been distributed, the valve cuts off. Now you can leave the card in and go through the process again by hitting the button and getting another jerry can of water, or you can just take the card out and walk away. One of the questions that we kept getting asked was the reliability of the cards themselves. These are RFID cards, and people were always confusing these with magnetic strip cards that have been used in a variety of ways. This particular card was written to and read from 100,000 times without failure, and we had numerous other cards that were written and read from thousands and thousands of times without failure. The valve and the flow monitoring system have gone through at least 15,000 operations without a failure. So we don't feel like reliability of these particular components is a very significant problem for a pilot test. Now, one of the biggest advancements that we have made in the system is on power consumption. We're actually running at 1/10 of the power of the original prototype. This particular standard 9-volt battery is able to distribute 1,000 jerry cans of water. That's pretty good. Now, we're not going to use this battery in the field test. We're going to use this battery. This battery is 3 times stronger. It's a lithium ion, and can go weeks and weeks without a recharge and distributed water. However, it has the ability to be trickle charged by a solar cell each day to make up for the operation cost. Now, we have gone through our data and we've taken a look at the specs on this particular solar cell. We're talking minutes a day to recharge this battery for the operations of one day, which is, we're considering about 50 people a day. We're talking less than 30 minutes. That's incredible. So we should be able to go weeks without any problem on power and still be able to distribute water. So we've made a lot of advancements on the electronics, the reliability, and the power consumption with the Q2 system. Like I said, we really want to develop and implement a pilot program so we can really document the importance of moving tap stands closer to people's houses for better quality of life and better communal hygiene.